Hey everyone! Today's screencast is all about the properties of logarithmic functions. We're going to use the product, power, and quotient rule, and we're going to simplify logarithmic expressions and exponential expressions, I should add. So let's jump right into it. So the first rule we're going to learn about, the first property is the product rule. And the product rule says for any positive numbers m and n in any logarithmic base a, the log base a of m times n is equal to the log base a of m plus the log base a of n. So basically, in the argument, you're going to separate them and add them as separate logarithms. So for example, if we have some expression like the log base 4 of 64 times 16, that's equal to the log base 4 of 64 plus the log base 4 of 16. Now, I can actually figure out the log base 4 of 64, which is 3, and the log base 4 of 16, which is 2. So this expression is equal to 5. Okay, let's look at another example. Can we go backwards? And this is more abstract because we don't know what x squared and y to the fifth is. But because I see, now this is what's important, the same bases, these are both a base of 3, and there's an addition sign between these, I can combine these and write one logarithm with the base of 3, and the argument, what's in the parentheses, is the product of the two arguments here. So it's x squared times y to the fifth. Okay, the next rule is the power rule. So the power rule says if we have positive numbers m and log base of a and any real number p, the log base a of m to the p is equal to p times the log base a of m. Let's look at how that works. So when we have the log base a of the cubed root of 17, the cubed root of 17 is the same thing as 17 to the 1/3 power. And the power rule allows us to take that exponent and write it in front of the logarithm. So it's equal to 1/3 times the log base a of 17. Look at another one. The natural log of x to the 8th is equal to 8 times the natural log of x, just bringing the 8 down in front. Okay, now let's look at an example where we have to go backwards. So if I had 2 times the log base b of y, now what you're going to do is to write this as, or to condense this, so to speak, we're going to take that 2 and make it an exponent. So it's equal to the log base b of y squared. The next property is the quotient rule. And the quotient rule says that for log base a of m divided by n, we're going to write the difference of the logarithms. So it's the log base a of m minus the log base a of n. Look at this one at work. For example, the log base 4 of x divided by y is equal to the log base 4 of x minus the log base 4 of y. Now go backwards. The log base a of 17 minus the log base a of w. Now, since I see that's written as a difference, I know this is a quotient. So it's equal to the log base a of 17 over w. It's very important that you notice here, there isn't a log written on top and bottom. There's one logarithm. You don't want to make that mistake. Okay, now let's put all of this together. So express the following in terms of sums and differences of logarithms. So we're going to work on separating this, and we're going to use the power rule, the quotient rule, and the product rule. The first one we're going to apply here is the quotient rule. So what I'm going to do is separate what's on top from what's on the bottom. Remember, I can do that with a subtraction sign. So I have the log base b of what was on top, a y to the fifth, minus the log base b of what was on the bottom, m cubed n to the fourth. So the next thing I'm going to do is use the product rule to separate those arguments, this one and this one. So when I separate those, I get the log base b of a plus the log base b of y to the fifth minus, now all of this is going in parentheses, the log base b of m cubed plus the log base b of n to the fourth. Now in this last line, I'm going to apply the power rule, so bring all of these exponents down in front. At the same time, I'm going to distribute this negative. So our final answer is log base b of a plus 5 times the log base b of y, see what happened with this 5, minus 3 times the log base b of m, minus, because I distributed the negative sign, 4 times the log base b of n. Okay, one last example. We're going to go backwards. So we're going to start with an expanded expression and condense it. So this is expanded. Let's bring it back like we did with the beginning of the last problem. So we're going to go backwards. So we're going to do the power rule first. So we're going to take care of all of those exponents. So it's equal to the natural log of x minus 1 plus the natural log of the square root of x. Remember, x to the 1/2 is the same as the square root of x. Then we have y squared, and then we have x plus 2, which is in parentheses, to the 4th power. The next thing we're going to do is use both the quotient rule and the power product rule. So I know that I have a quotient. I know I have a top and a bottom to my expression. What goes on top are all the terms here that are positive. What goes on the bottom are the terms that are negative. So look at this final answer. On top, we have the square root of x times x minus 1, which is in parentheses. And on the bottom, we have y squared, because there's a negative here, times x plus 2 to the 4th because of this negative. Take a look at that answer. Notice one natural log. You're not going to write it both on the top and the bottom. There's only one. And then this whole expression is in parentheses. Or, I'm sorry, is the argument. Okay, the last thing I want to do is 2 more properties that help us to simplify log expressions. So the first one is the logarithm of a base to a power. So it says if you have log base a of a to the x, that is going to be equal to x. That should make sense. The bases are the same here. We have a base for the logarithm and a base of the exponential part. They're the same. So it makes sense that the exponent's going to be equal to x. Let's look at how that works. The log base a of a to the 9th is equal to 9. The natural log of e to the negative 6k power. Sometimes students get tripped up on this problem. See, the natural log, remember, means log base e. So these bases are the same. You don't see the base for the natural log, but we know that's there because it's the natural log. And so the answer is negative 6k. Same thing with a common log problem. The log base 10 of 10 to the negative b power is going to be equal to negative b. The last property today is the a base to a logarithmic power property. So for example, if you have a to the log base a of x, that's also equal to x. Let's look at some examples. So first we have 7 to the log base 7 of x. Because these bases are the same, this answer is x. Look at another one. e to the natural log of 5. Remember, natural log has a base of e. So since those bases are the same, the answer is 5. And then a common log example, 10 to the log base 10, the common log, to the log of 7g. It looks kind of funny, but that's 7 supposed to be multiplying the g. And so that answer is 7g. Here's a summary of all the properties we learned today. I think it's a good idea to write those down, have them on a nice piece of paper that you can refer to when you're doing your homework. All right, good luck. Let me know if you have any questions.